Welcome to the Electrical and Electronic Engineering Lecture Series. Your anchor person is Professor Michael Sindinechi. Our topic today is Understanding the Internet Technology Part 1. As you know, the Internet technology is reshaping the world, and many people make use of Internet without actually knowing how the whole thing works. They always think that internet is one computer connecting to another computer. Yes, it may be so, but in this lecture, we want to bring out exactly what the technology behind the internet is. And we'll be able to also let you know the services that are available in the internet for you and how you can make maximum use of the internet. So please follow me in this lecture series by subscribing to my YouTube channel at https://youtube.com/@Ndinechi Please like, share, and drop your comments in the comment section or reach out to me using my email address. I also enjoy you to subscribe so that you can get to notice when the part 2 of this lecture will come up. It's going to be a short one because my audience, I know, is not only electrical engineering students, but anybody. So I'm not going to stretch it for more than 30 minutes. You are welcome. So, by way of introduction, the internet is a large-scale public packet switching network that is operated by a group of carriers called the Internet Service Providers, which is denoted as ISPs. I'm sure many of you will be hearing ISPs. It stands for Internet Service Provider. So each carrier is known as a backbone. So people own backbones. We will see shortly what, the picture of a backbone. So a backbone network is a high-capacity packet switching network that uses high-performance routers and is interconnected by high-capacity transmission lines. The ISP industry was created in 1993 when the US government ended the subsidy on internet. Since then, it has been operated as a joint venture. Now, we say something here that the ISP industry was created in 1993 when the US government ended the subsidy on internet. Before that time, the internet was a brainchild of the American Department of Defense. But while they were operating it, they found out that it can provide even far more services than just what the Department of Defense needed. So they went into, providing such services, extending it to, civil use, And before then, the government was in charge. But when it became a full-scale business, then the US government had to pull out. And when they pulled out, then the internet service providers come together as a joint venture to keep it going. So to form the internet, the backbone networks are interconnected at a number of special connection facilities called the network access points, as we can see in Figure 1 shortly. The general public, or to the general public, the internet is just a data communication link between entities. In commercial data communications, however, the internet is simply another network application and another set of services to be accessed. While many people confuse the internet with the World Wide Web, the internet itself is a collection of interconnected packet switching networks built on what is known as IP technology. IP means Internet Protocol Technology. And in communication systems, when we talk of protocols, we are talking of an established rules that enables different devices to establish a handshake. We call it protocols. So if you look at Fig 1 here, you see the pictorial representation of the internet technology. You see the ones in green where we say backbone 1, backbone 2, backbone 3, and so on. So, group of internet service providers all have the backbones. If you look at backbone 1, you see the equipment connected to it. You see the router, you see the firewall. As we go on, we will continue to explain each of these devices. You see the LAN users, you see your computers connected in local area network. But if we go back, you see that between backbone 1 and backbone 2, we have what we call the private peering. On top, we see what we call the network access points. Now, what happens is if the person in backbone 1 is looking for something in the internet, that thing he's looking for may be found in his backbone, which is backbone 1, or in backbone 2. If what he's looking for, because it's connected directly to backbone 1, and what he's looking for is not in backbone 1, but in backbone 2, then he has to go through the network access point. And from the network access point, it will take him or her to network backbone 2 or backbone 3 or the N backbone, no matter the one. It will find the thing and send back to the backbone 1 for the person to access. We see also dial-in users, people that are not dialing in through a local area network. As we go on, we explain more. If you use your phone to access the internet, you are regarded as a dial-in user. If you are using like your university Wi-Fi setup, you are making use of the LAN. So you are a LAN user. Now, we see what we call the private peering. If there is sufficient traffic originated from backbone 1 going to backbone 2, or from backbone 2 going to backbone 1, there could be an understanding between the operators of backbone 1 and the operators of backbone 2, so that connection between them will not go through the network access points, because going through the network access point may introduce delays and congestion. So they have common interest between backbone 1 and backbone 2. So two of them can agree and establish what is called private peering, so that they don't have to go through the other network, but two of them can easily communicate together. So you see that in a internet setup, you have LAN users that are connected to the backbone via the router and firewall. The firewall is a security device to make sure that things like viruses, unauthorized users may not get access to your local area network. Then that users die direct, while also you have web servers for people that try to resell. We will get to that point shortly. So within ISPs, that is internet service providers, the first important subdivision is between the backbone operators and the resellers. Private lines and asynchronous transfer modes, known as ATM, are the two types of transmission services usually used to connect to backbone routers. Private lines are usually high-capacity fiber-based services operating at 155 megabits per second. This 155 Mbps is usually known as STM1. So you'll be hearing people ask, what is the capacity of your internet? And we say, we have STM1. STM stands for Synchronous Transport Model, which offers 155 Mbps capacity. So in some cases, backbone connections are through ATM services. When we say ATM services here, we are not talking of the automatic teller machines, but asynchronous transfer mode, which is a technology used in data communications. So in some cases, backbone connections are through ATM services, which are special high-capacity packet technology that uses fixed length packets called cells. As we go on to our part 2 and part 3 of understanding the internet technology, we'll be able to see what we mean by packet technology. ATM services can typically support access rates up to 622 Mbps. So you see that they offer even higher services than the STM1. Due to congestions in the network access point, most backbones are connected via private peering arrangements. Private peering is essentially network access points that are owned by the backbone operators and used to support one-to-one connection between backbone operators. Just like we see in the drawing, if backbone 1 has sufficient connection interest with backbone 2, two of them can agree and have a private peering arrangement so that they don't have their traffic will not have to go through the network access point to avoid possible congestions. Note, commercial consumers are continuously searching for how to use this packet network to replace other network services. The internet is now operated as a joint venture, and there are hundreds of internet service providers the world over. So commercial users typically connect their devices to the internet for use in a variety of ways. It could be as a web page hosting. We say every commercial entity maintains a web presence that is accessible through the internet. Of course, if you are looking for anything now, you want to buy something, you go to the web page of the company. So the company is a commercial entity. So for it to be useful in the digital economy era, it has to have a presence in the internet. And that having presence is called web page hosting. So the internet can be accessed through the web access, through external email, through virtual private network applications. As we go on, we will talk on all this because some of us have VPN apps in our phones, but we don't know what they are there for. So the next level is internet resellers and points of presence. Now, while the user sees the internet as one big network, it is actually a number of independent interconnected networks administered by independent backbone operators who build and maintain their own backbone and sell services to the customers. Beside the backbone operators, there are thousands of internet service providers who simply resell access from the backbone. Each reseller is aligned with one or more backbone operators and signs up customers. The resellers may operate their own access equipment to support their customers and channel traffic to their backbone suppliers, or simply use the backbone operators' access equipment. I want to quickly point out here that the reselling occurs at different levels. For instance, somebody can connect, internet to his house or even in his phone and decide to resell it to, somebody close to him. That could be at the lowest level, but some people can, when you buy data, you are buying from a reseller because the backbone operators do not have the, do not sell to direct users. So they resell, then it goes down, it goes down. For instance, if you pay for your university to allow you to make use of the university-wide Wi-Fi, you are paying to university and the university is acting as a reseller because they will also get from another person. So we call this chain internet resellers or point of presence POP because they help the backbone operators to establish a presence in a particular place. So the internet service providers maintain operating centers or what is known as point of presence around the whole world. In Nigeria, we have the uh, one backbone operator, which is called the Galaxy backbone. So they should maintain presence all over the world where they also help to sell internet services to people. So a typical point of presence configuration is as shown in Fig 2, and usually we include the LAN switch. When we say LAN, we mean local area network switch. So where you work, I will, ask you, you can go to your Information and Communication Technology Center, ICT centers, and ask them to show you what a LAN switch looks like. So all the components in the point of presence are connected through a high capacity LAN switch. You also have the backbone routers, and we say that they are very high capacity routers that connect to other POPs or NAPs. Normally, each backbone router will have a redundant hot standby. Now, most of the time, when you read things, you hear hot standby. What does that mean? In communication systems, you don't allow downtime because that downtime may cost you so much. So you must have a parallel working channel. One will be redundant, but two of them will be working. One is being used, and as anything happens to that one, the other one takes up immediately without the user noticing that something has happened. Take for instance, in your house, you have an automatic generator that takes over when the power source fails. So now, if you don't wait for power to fail for the generator to come on, it means that that generator is on hot standby because when you are using the public power supply, the generator is on in case the public power supply goes off. In that case, you say that the other one you are not using is on hot standby. So in communication systems, you don't just normally put one equipment because it can fail. And if it fails and there is none on hot standby, it becomes, they may cost you dearly. So we also have what is known as access routers. So these are routers that support dedicated connections from customers. Some customers may want to have dedicated connection and not the one shared with other people, so that they will be sure of it. As we go on, we explain further. These access routers channel traffic through the LAN switch to the backbone routers. This is the pictorial view of what we are talking about. You see the access routers, which are being used by dedicated users. You see the massive equipment at the center, which is the LAN switch. Of course, you see the remote access servers, which people use to access the LAN switch via the public telephone network. In our case here, this public telephone network could be going through your network operator, that is your cellular network operator, such that from your phone through your network operator, you get access to the internet. And when you do that, we call you dial-in user. So you also see the email servers that are, are attached to the LAN switch. You also see what we call the domain name server. When we talk of this domain name server, you see some people, when they have email address, the email address reflects where they work, and not just at gmail.com or at yahoo.com, but at where they work, and so and so. That means that they have this type of server called the domain name server. And of course, you have the other servers hosted by ISPs. For instance, your university may have a whole lot of data where they store students' record, which you normally call portal. Yeah, those things are stored in this ISP hosted customer servers. In some cases, if you send mail, if you start your system, you can record that mail, and after you close the mail. Those mails are not saved in your laptops or in your desktops. They are saved somewhere, and they are saved in these ISP hosted customer servers. So don't think that because you use password to protect your email, that another person somewhere do not have access to those mails. They do. The person that owns that, ISP hosted customer server can have access to your mails. So, of course, you have the backbone routers. Note that sign in blue. That is the circuit sign for routers. Now, we quickly, talk about them. The remote access servers, these connect to the public switch telephone network and support dial-up customers. Servers that support email or other network services also connect to the LAN switch, like the domain name servers. Customer web servers are those whose web servers are located at the ISP's point of presence, and we normally connect to the LAN switch on 100 Mbps Ethernet interface. As we go on, the Ethernet is also a technology that are used to operate local area networks. We will get to it in our subsequent lectures. It's a note. Sometimes people confuse internet and intranet. It is important for us to define, when we say intranet, what we mean. Intranet refers to an application idea which uses web servers and web browsers to disseminate internal information. You will confuse with internet when you use it, but it is really an internal information interchange. Another internal information could be uploaded on a server in a web format using what is known as the HTML, hypertext markup language, and users could access that server over the local area network and display the information with a browser. What you are saying here is that you can, you have your browsers. It could be, Firefox. It could be any of them. So you go there and search for, use it to transfer information within your office, more especially where you have big offices. You may think that, it is going through the internet. No, it is not going through the internet, but the intranet, but making use of all the facilities that are used for the internet. So, what access available to you? We say internet access. Consumers rent access to the internet from either a backbone supplier or a reseller. We said it is not usually through backbone because they are big enough to start selling to small customers. The capacity of the access connection is a major factor in the performance from the user's perspective. With a high capacity access, web pages, emails, and data can be uploaded or downloaded more quickly. If there are multiple users sharing a connection, the transmission control protocol, which is ordinarily noted as TCP, automatically shares the capacity equally among all simultaneous users. So you see, if you are using your phone to browse, and there are so many people within that place using their phone to also browse using the same network, you can see that there will be, the system becomes slow, the latency becomes high. What we mean by latency is that when you, try to load something and you see a small circle continues to turn and turn and turn, we call it the latency time. So also, you can see when some people are doing something, you see mobile networks bring mobile transmitters and antennas. What they are trying to do is to help to provide more, capacity so that the latency time will be shortened. So let's look at Fig 3 to see a typical topology of an internet access. So now, if you want to access the internet as a dialing user, you can use your modem. Modem, I'm sure many of us remember modem. When we go to our network operators to buy, our cellular network operators to buy a modem, anytime you want to use the internet, you connect the modem to the USB port of your laptop, and there you go. So when you do that, you see that you are a dialing user who is connecting through your public telephone network, and your public telephone network, which is your cellular provider. Now, when we say cellular provider, we are talking of companies like in Nigeria here, MTN, Glo, Airtel, and so on. They are the public telephone network providers. So they themselves, through a remote access server, gets to that LAN switch, which is owned by either a reseller who has the point of presence that covers where they operate. Also, you can have a dedicated server who is using a high capacity of between 2.048 or 34 Mbps private lines. For instance, banks can have dedicated access so that they don't have to depend on the cellular providers to, access their branches. So they are called dedicated access. And they have their own separate routers that connect direct to the LAN switch. So now, this your connection can be of two types. It can be of asymmetrical or it could be a symmetrical access. Now, let's see the difference. An important factor in access of internet is whether it is asymmetrical or symmetrical. Symmetrical internet access means the access connection has the same capacity in each direction, whereas asymmetrical means that the downstream channel, that is transmission towards the user, has greater capacity than the upstream link. We want to explain that. You see, symmetrical means access connection has the same capacity in each direction. That is, you use your phone, your sending message has the same capacity as the message coming down to your phone. Whereas in the asymmetrical, your sending message takes small percentage of the capacity because you are more likely to download probably pictures, big files. So the download link, which we call the downstream channel or the transmission towards the user, has greater capacity than the one going from the user. So for the asymmetrical connections, there are always more heavily weighted downstream because the ratio of downstream to upstream web traffic is usually between 20:1. And in some cases, even up to 40:1. So if the user is uploading large files, the upstream channel can become a bottleneck, and a symmetrical access would be more appropriate. But in most cases, people don't send large files upstream as much as they look for large files downstream. So in some cases, the asymmetrical network will be on its own. That is why when you are using your internet on your phone, you can be from time to time seeing maybe changes to H, G, or the showing you different rates. So, but the access options available for use is what is known as dedicated E1 or E3 option. So this refers to the symmetrical digital private lines connecting a customer location to the ISP point of presence at 2.048 Mbps and 34 Mbps respectively. So if you're using dedicated E1, what your transmission rate will be is 2.048 Mbps. And if you're using the E3, it will be 34 Mbps respectively. So we've talked of the modem, which we call the dial-up modem. The most prevalent access for residential and traveling users is this dial-up modem connection, which is asymmetrical in nature. The modem automatically selects the highest data rate which it can be which it can support based on the quality of the connection. So remember, if you had ever used the modem, if you connect it, it will be showing you, is it HPA? Is it 2G? It will keep showing you, different quality of connection. So anyone it sees is what it connects to. We also have what we call the broadband access. This is a new set of higher speed. For instance, you go out here, they have broadband network. So what are these broadband networks? Because they give you higher speed and more convenient access options. And these options include what is known as WiMAX, wireless access. WiMAX stands for Worldwide Interoperability for Microwave Access. So some private people also make use of WiMAX to access the internet. And say this uses point to multi-point microwave radio transmission. WiMAX is the marketing name for products certified to comply with the IEEE 802.16 standards and supports data rates up to 1.5 Mbps. Now, most of the standards used in internet communication is established by this body known as the IEEE, that is Institution of Electrical and Electronic Engineering. So they've established this standard called WiMAX, which delivers up to 1 Mbps. You also have what you call the cable modem. The more popular residential broadband option is cable modem services. This is not, very much in use in Nigeria, but for people that enjoy the Starlink, internet services, this could be, something like that. So these services, the cable, can also be delivered over coaxial cable that is used to deliver TV in your houses. The downstream channel operates on an unused 6 megahertz. Now, there is something we want to, note here. For those of us that have been following some trends, was a time the issue of TV white spaces were being discussed. And, in some countries, they have used that TV white spaces because as you transmit your TV channels, there are spaces that are available. So some people make use of that slide spaces to transmit internet access. So you have the ADSL, which stands for asymmetrical, and SDSL, which stands for symmetrical digital subscriber lines. And these operate over copper telephone wire and delivers downstream rates up to 6 Mbps. Now, this happens where they, still have landline telephone system. We may not see such in Nigeria now because we no longer operate the landline telephone services. So you can also access the internet through satellite. And most time when you see your DBS, which we call the direct broadcast satellite, example of this direct broadcast satellite is your DSTV dish. You connect and, when the people connecting it, they will show you that, if we put it here, it will not be seeing the satellite. Yeah, it has direct access to satellite. So we say DBS providers offer satellite-based internet access service, but the service is slower, about 200 kilobits per second to 400 kilobits per second downstream. The cost is more expensive than the ADSL and the cable modem. It is rarely used except where there are no other high-speed options. Good choice for rural areas, because if they cannot get high-speed one, they make use of the satellite where there will be no stations, substations, or wire connections. Now, the one that is more common to us is what is known as wireless ISP or WISP. So operators of WISP offer internet access using the IEEE 802.11, otherwise known as the Wi-Fi. This one is known by everybody. So everybody now talk about Wi-Fi. So this is the type of internet service providers, which is also a standard of the IEEE 802. So in the electrical engineering balance, you don't talk about Wi-Fi. You just say IEEE 802.11 standard. So we say that this technology to register subscribers in public locations called hotspots. So if you enter a hotel, if you enter an airport and you see there is a network here, what you're seeing is that you are automatically connecting to their local area network of that hotel. So we want to give you access by giving you access to log in. So we leave it open depending on how much money they want to spend in providing the access. So the Wi-Fi is also a form of internet service provider, because each person gets his local area network and leave it open for people to connect, known as the Wi-Fi. So the wireless access point is usually connected to the internet on the E1 or similar speed connections. Now, new things keep coming up. So you see that from the Wi-Fi, the technology starts increasing in speed, and that is, we started having what we call the 2.5G generation, 3G, and LTE wireless access. Now, this LTE is what you know now as 4G. The real name is long-term evolution. So, but in order to get it, sequence with the 2.5, 3G network, it is, ordinarily known as 4G. But the real name is LTE, wireless access, which we say is equivalent to what we call 4G now. So these are services introduced by cellular carriers. When we talk of cellular carriers, we are talking of networks like in Nigeria here, MTN, Airtel, Glo, Nine Mobile, although they are cellular because they provide cellular telephony. So these are services introduced by the cellular carriers to deliver higher speed data services over their existing infrastructure that can be used to access the internet or corporate applications like email. Users can access the services from their cell phones, their personal digital assistants, and wireless modem cards installed in laptops. So let's quickly see what happens when you want to access the internet. You say there is a web session for you to go to internet and come out. It's called a web session. So anytime a user enters a www address and clicks go, a number of interrelated elements come into play. Remember, you are searching for, something. You go to your URL, you type in some systems. If you type in, it will automatically on its own append https dot column slash then www dot the address. In some, you'll be required to put the thing yourself. So when you do that, the HTTPS means hypertext protocol, and the S there stands for secure. There is what is called security in web browsing. If you go to a network and you type that HTTP and the S did not come, you are taking a risk because your system may be infected with virus. But if you see that S, it means that the network you are going into or the page you are looking for is a secure page. Nothing will happen to your system. So anytime a user enters the www address and clicks go, a number of interrelated elements come into play. Let us look at them sequentially. Look at this diagram, similar to the first one we saw with backbones 1, 2, 3, and N. Now, a dialing user dials in to access the internet. We will quickly explain what happens, but I want you to note the arrows we have. We have the arrows in green, in yellow, and well, that one is not pure yellow, maybe orange, I call it. So let's quickly look at that. So in that diagram, you have server on the right. You have domain name server. Look at it up there. You have network access points. You have dialing users. So let's quickly see what happened. When a user enters the URL means the Universal Resources Locator. You want to locate a resource, you don't know where it is. So what you do is you type that thing you are looking for. So where you type it is known as the URL, Universal Resource Locator. So when you enter the URL on your browser's command line, a request is sent to a domain name server that looks up the URL in a table and returns the IP address. When we talk of IPs, Internet Protocol, I've tried to explain at the beginning what the protocol is. The DNS are arranged in a hierarchy. So if the local DNS does not have the address, it forwards it to the next DNS in the hierarchy. At the top of the hierarchy are the root servers. When the device receives the IP address from the DNS, it generates an IP packet, inserts the to and from address, and forwards a TCP connection request into the network. When the TCP connection is made, the web page is sent. If the server is in the same backbone as the client's server, the routers in that backbone will forward the IP packets to their destination. If the server is in another backbone, the IP packets will be routed to a network access point or a private peering point, forwarded into the backbone that holds the information, and from there be routed to their destination. Now, the web page is downloaded over the TCP connection in a series of IP packets. Once the web page is downloaded, the DCP connection is terminated. Now, let's quickly mention this. Cookies. The web server can also request for short files called cookies that provide information such as other websites or pages the user has requested. In that way, even though each page requested involves a separate TCP connection to the web server, the user will have the impression that they are involved in one uninterrupted conversation. If any of those IP messages are lost during the download, the TCP automatically orders a retransmission. If there are too many lost packets, TCP may quit and the download freezes. In that case, the client will have to hit the resend button. Now, let me explain this in a more friendly way. So when you enter the URL of what you are looking for in the browser and click go, the system will look at the domain name server. Assuming you are in a university, it will look at that domain name server to see if what you are looking for is within that server. If it didn't see it, it will give an appendix. That appendix is the name of the equipment that is looking for that thing, and append another to send it to the next higher DNS after it. If that one searches and didn't get it, it will do a similar thing and send it. It will continue like this until it gets to the backbone. If it is not in that backbone, it takes it through the network access point to another backbone. So until it finds that thing, because it always appends the to and from address, it will continue like that to carry that thing back to the original system or original equipment that make the request. Immediately it drops that thing, that request at the original system that made the request. The whole communication terminates. So, to you, it looks as if you just did this and it comes from the next system. No, a lot of things happen. So, in our next lecture, we'll be seeing what effort this thing is making to get this information from you, which is termed that the system is making maximum effort, but you can't hold it if it fails to get that. If it is bringing the information back, it notices that there are losses. The system can send you error. In some systems, it tell you error 404, showing that it has lost enough packets that there is no need. So you can retry. When it tells you it failed, you can refresh, you can resend. If you click the resend button, the thing can go. Probably as it's coming back, it will not lose packets. So that is why at times you click, you don't get anything. If you click again, the thing comes immediately. And each time it's making the maximum effort to get you what you want, but it's not, it doesn't owe you anything to get it. If you can't get it, it tells it fails and you can't do anything. In our next lecture, we'll be able to see why there is service level agreement. In some cases, when you get a system and you are filling up, they ask you to fill the service level agreement. So we will see how that come into being, and that is why in most cases people require private dedicated lines. So thank you for listening. How I wish you will join us next week when we will continue with this understanding the internet technology part 2. In that case, we will see how virtual private networks are now making use of the internet, because this internet, even though it's free for everybody to connect, that is also how everybody that connects be problem to you. We will see how internet starts to, take care of that. Thank you for listening and hoping that you will join next week when we'll be talking on part 2 of understanding the internet. Please share, make your comments, ask your questions in the comment section. I will go through the comment sections and answer all questions. Thank you.